Morning to everyone. This video posted by SRM Engineering College affiliated to Anna University, Chennai, India. Why we have to posted this video? Mostly probably benefit of engineering students such as matrices and calculus study the students. Under the paper code is MA3122. Yeah, I am happy to share. This is Dr. Palanikumar, SRM Engineering College, Assistant Professor, Department of Mathematics. I am happy to share. I am one of the top two scientists in the world. Stanford University, approved by USA. Yeah, this is very good university in the world. Overall, this university covered by all research and development centers. This is also my profiles and Google Scholar citations and my Scopus citations and also my in-text documents, Scopus in-text documents. Yeah, I am happy to share this video. Now I call upon that means I have choose the topic Gauss divergence theorem. Yeah, this is the main topic of the vector calculus. Statement of the theorems. The surface integral of the outside normal component of a vector field over a closed surface is equal to the volume integral of the divergence of the field. This is a theoretical. We have converted to the mathematical form is denoted as double integral over S. That means double integral over surface F dot n ds is equal to the triple integral. That means triple integral is is also is called a volume integral. Del dot F into TV. So this is a main theme of our lecture. So this is a statement of the Gauss divergence theorem. First of all, how to find del dot F? The divergence of F at a point P is x naught, y naught, z naught at a point in the Cartesian system is given as del dot F is equal to F, that means differentiate with respect to x plus differentiate with respect to y plus differentiate with respect to z. Hence, del dot F is equal to dou f by dou x plus dou f by dou y plus dou f z by dou z. This is a Cartesian coordinate system. So this is a main theme of the Gauss divergence theorem. Yeah. Evaluation of del dot, how to find. So this is a cuboid, x-axis, y-axis, z-axis. So this is right hand side. So differentiate with respect to dy. This is also front side. Differentiate with respect to dx. This is top side. This is similar to find dz by dx. So this is required. We have to find volume of the sphere. So the divergence of a vector field at P is a point. So positive divergence, negative divergence, zero divergence. For an example, the divergence is positive sources in the field. A negative a sink spoil of this field where neither sink nor sources. This is a zero divergence. So again I tell us the positive is divergence is source field positives. A negative divergence at the sink point. So whether there is a neither sink or no source is a zero divergence. So the figure A is a positive divergence. So figure P is a negative divergence. So third one C is neither positive nor negative. That means zero divergence. So conditions is surfaces must be closed. So these are conditions. Suppose the problem solved, cause divergence problem solved. These conditions must be satisfied. So surfaces must be closed. Second condition, vector field must be continuously differentiable. Third one, orientation must be outward normal. So these three conditions are satisfied every cause divergence problem. So hence the cause divergence problem is fully satisfied. For an example, so physical interpretations. The theorem related flux through a surface to surface sink inside the volume. Steps to apply. So suppose we can find cause divergence. These steps are must be followed. Step number one, find divergence of f. Second one, evaluate triple integral over the volume. Third one, evaluate surface integral. Fourth one, verify the equality of the conditions. So these three are conditions are satisfied. We can solve the problem is also fully satisfied. Verify cause divergence problem. Suppose I can choose one of the problem. F vector is equal to x cube minus yz into I vector minus 2x square y j vector plus 2k vector. And S is the closed surface of the cuboid founded by x varies from zeros and 1, which is included zeros and 1. This is closed curve. So y varies from zeros and 1. Z varies from again zeros and 1. So this is a given problem. We can apply cause divergence. So step number 1. So volume integral. So right hand side. So we can check it. So step number 1, divergence of f. So already I told that del dot f how to find. That means f differentiate with respect to x plus differentiate with respect to y plus differentiate with respect to z. So sum of all these is equal to some quality of the value. So now we can find del dot f dou by dou x of x cube minus yz. How to find x cube minus? We have to find I vector corresponding to the I vector. We have to multiply I dot I, j dot j, k dot a, all the quantities 1. Otherwise, other combinations are 0. So hence, del dot f equal to dou by dou x of x cube minus yz plus dou by dou y of minus 2x square y. So plus dou by dou z of 2. So differentiate with respect to x quantity. So x cube minus yz. X cube is arrival at x, which is differentiate with respect to x. So 3x square is not independent of the term yz. So hence 0. So x 3x square minus 0. So differentiate with respect to y. So minus 2x square is independent of the term in y. So we can keep it as a constant. So differentiate with respect to y. So is equal to 1. So minus 2x square plus dou by dou z of 2 is independent of the term z is equal to 0. So hence 3x square minus 2x square plus 0 is equal to 2x square. So this is del dot f. Again we go to find step number 2. Step number 2. Triple integral over the cuboid. So the statement triple integral over b x square dv is equal to, so we can find del dot f is equal to x square. So our formula is triple integral over v del dot f dv. So we can find the del v. Now triple integral over v x square dv is equal to, so the value is given. Find the range 0 to 1 x 0 to 1 0 to 1 0 to 1 x square dx dy dz. So the first integral value x lies between zeros and 1 is integrated with respect to x. So x square is integration is x cubed by 3. So these all the values are 3 constant limit. So you can integrate is easy to find. So x cube integration with respect to x, the value x cubed by 3. Upper value, lower value we can find. The value is 1 by 3. Again, we have to integrate with respect to y. So the value, again, integral with respect to z, again the value. So hence, this value is equal to 1 by 3, is value equal to 1, this value equal to 1. Hence, the value is 1 by. So, next, second step, number 2, surface integral. So, left hand side. Flips through each faces of the cuboid. The first face at a point x equal to 1, x equal to 0 and x equal to 1. At if x equal to 0, f vector is equal to, so our problem is f vector, we can substitute x equal to 0. So minus y z and I vector plus 2k vector. Here upward normal is minus I vector. So we can multiply it. This is n vector. That means I vector is equal to 1. So f dot n cap is equal to minus yz into minus 1 is equal to yz. The integral 0 to 1, 0 to 1, yz dy dz. We can integral with respect to y square by 2. The value is 1 by 2. Again, integration with z square by 2. The value is 1 by 2. Finally, we get 1 by 2 into 1 by 2 is equal to value is 1 by 4. Similarly, we can find at a point x equal to 1, f vector is equal to, so we can substitute x equal to 1 in the given f. 1 minus yz into I minus 2yj plus 2k. Here, the upward normal is plus I vector. So we can multiply I dot I is equal to 1. So remaining the other quantity I dot j, I dot k, the value is equal to 0. So now f dot n cap is equal to 1 minus yz. Our surface integral is double integral over f dot n cap int dy dz is equal to integral y with respect to 1 minus of yz. Our routine calculations, the value integral 1 integral with respect to y is equal to y. The range is 0 to 1 minus y is it independent of the tau method. We have to integrations y square by 2. Upper limit, lower limit, we can substitute. Again, we have the integral with respect to z. Finally, we received 3 by 4. Total flux through x faces. So totally already given it 3 by 4 minus 1 by 4 is equal to 1 by 2. This is one steps. So now case 2, y equal to 0 and y equal to 1. Now f dot n cap is equal to minus 2x square y. At a point y equal to 0 plus x equal to 0, we can substitute at y equal to 1. Double integral over minus 2x square dx dz is equal to x square. We got the integral with respect to x square x. So minus 2x cubed by 3, we can upper limit minus lower limit. So minus 2 by 3. Again, we integral with respect to z. The value is 0 to 1. Now we can find the value is equal to minus 2 by 3. Is z equal to 0 and z equal to 1. Now we can, given the value f dot n cap is equal to 2, question is 2, at z equal to 1, flux is equal to 2, at z equal to 0, the flux is equal to minus 2. So we can add these two, that net flux is the value is equal to 0. So now the total over surface flux is equal to double integral over surface integral f dot n cap ds is equal to, in all the cases, case number 1, the value is 1 by 2. Case number 2, the value is minus 2 by 3. Case number 3, the value is equal to 0. So sum of all the cases, so the value is equal to 1 by 3. Now we conclude that Gauss divergence theorem simplifies Fluke's calculations by converting into the surface integrals to the volume integral. Now, hence our conclusion that left hand side value is equal to right hand side. So, our given the problem is Gauss divergence theorem is fully satisfied. So, these are the applications of our Gauss divergence theorem. We can applicable for fluid mechanics, is also applicable for electromagnetism. The Gauss divergence theorem is very interesting results is applicable to heat transfer. Also, many several field is like engineering analysis. These are the very powerful applications of Gauss divergence theorem. Is very interesting results. Future is like various applications nowadays going new research under process going. Thank you for watching the videos.